Course 3, Industrial Processing, Resource Efficiency and Waste Management in Food Systems, Raw Material Control. This module introduces the principles of raw material control within industrial food supply chains, focusing on how sourcing decisions, raw material quality, and supply chain dynamics affect processing efficiency, food safety, waste generation, and sustainability performance. It examines industrial supply chain structures, upstream-downstream dependencies, and sourcing models with particular attention to traceability, regulatory compliance, and supply risk management in the European context. The content addresses practical approaches for evaluating raw material usability and value, including physical, chemical, functional, and economic criteria, and explores strategic sourcing and inventory control methods to improve resource efficiency and resilience. Material flow analysis is presented as a key tool for mapping inputs and outputs, identifying loss points, and quantifying food loss and waste in processing operations. Best practices in raw material handling, hygienic design, process standardization, and operator training are discussed alongside strategies to reduce avoidable waste and manage unavoidable byproducts. The module also introduces waste valorization pathways and circular economy principles, including energy and water-efficient technologies and cross-sector reuse options. Digital solutions for waste monitoring and inventory optimization are highlighted as enablers of data-driven decision-making and continuous improvement. After completion, learners will be able to describe supply chain dynamics and raw material sourcing patterns, and evaluate the usability and value of raw materials in different processing contexts. Industrial food supply chains are complex, multi-tier systems that connect primary production, processing, distribution, and retail. Their main purpose is to move large volumes of perishable raw materials efficiently while maintaining food safety, quality, and economic value. Unlike other industries, food systems must handle biological variability, strict regulations, and time-sensitive logistics, all of which strongly influence processing efficiency and waste generation. Raw materials originate from agriculture, livestock, and fisheries, where production is naturally variable. Weather conditions, seasonality, pests, and disease affect both quantity and quality. As a result, incoming raw materials can differ significantly in size, moisture, composition, and safety risk. This variability has a direct impact on yield, energy use, and waste, making raw material control a critical function in industrial processing. Intermediaries such as cooperatives, traders, and wholesalers play a key role by aggregating raw materials from multiple producers. They often carry out early quality grading, storage, and logistics coordination. By filtering unsuitable materials before they reach processing plants, intermediaries help reduce downstream waste, stabilize supply volumes, and lower transaction costs for processors. Processing is the central transformation stage of the food supply chain. Raw materials are converted into products through operations such as milling, cutting, cooking, fermentation, freezing, and packaging. These facilities are capital-intensive and rely heavily on consistent input quality. Variability in raw materials can disrupt operations, reduce yield, and generate avoidable waste if not properly managed. Downstream actors, including distributors and retailers, strongly influence upstream decisions. Retail demand forecasts, quality standards, and sustainability requirements shape production planning and sourcing choices. When forecasts are inaccurate or demand changes suddenly, processors may overproduce or face shortages, both of which contribute to food waste throughout the supply chain. Supply chains are coordinated through contracts, standards, and certification schemes that define quality specifications, delivery conditions, traceability, and compliance requirements. Long-term contracts reduce uncertainty and stabilize supply relationships. Increasingly, environmental and sustainability criteria are embedded into these governance mechanisms, helping align incentives across the chain and reduce rejection-related waste. Upstream and downstream stages are tightly interconnected. Variability at the production stage propagates through the chain, affecting processing schedules and inventory levels. Shortages can halt production lines, while surpluses increase storage pressure and spoilage risk. Because biological production cycles limit rapid adjustment, buffer strategies and coordination mechanisms are essential for maintaining stability. Agricultural practices have a major influence on raw material quality. Sustainable practices such as precision farming and integrated pest management tend to produce more uniform and safer inputs. In contrast, poor practices increase contamination risk and variability, requiring additional sorting and processing adjustments that raise energy use and waste levels in industrial facilities. Poor coordination and information flow are major drivers of food loss. Inaccurate harvest forecasts, delayed communication, or logistics failures can result in idle processing capacity or spoilage of perishable inputs. Integrated planning tools and real-time data sharing help synchronize activities across actors, reducing mismatches and improving overall supply chain efficiency. Global sourcing provides access to large volumes of raw materials, price advantages, and a wider range of inputs. However, long supply chains increase transport emissions and exposure to geopolitical and logistical disruptions. Local and regional sourcing shortens supply chains, improves freshness and traceability, but may be limited by seasonality and scale. Many companies therefore adopt hybrid sourcing strategies. Processors may source either raw agricultural materials or semi-processed ingredients. Raw inputs allow greater control over quality and processing parameters, but introduce more variability. Semi-processed inputs improve consistency and simplify operations, but increase procurement costs and reduce flexibility. Choosing between these options requires careful evaluation of yield, waste, and operational trade-offs. Commodity-based sourcing focuses primarily on volume and market price, often allowing broader quality ranges. Specification-based sourcing, by contrast, defines strict criteria for moisture, composition, residues, and safety. Although this limits the supplier pool, specification sourcing improves processing consistency, reduces rejections, and lowers waste, especially for high-value or sensitive products. Sustainability criteria are increasingly integrated into procurement decisions. Certified raw materials help companies meet regulatory obligations and consumer expectations. Supplier audits and sustainability standards reduce reputational and compliance risks, while also encouraging responsible production practices that support long-term supply stability. Traceability is a legal requirement in the European Union. Food business operators must be able to identify suppliers and customers for each batch. Batch-level traceability enables rapid recalls and containment of safety hazards. Effective traceability systems reduce waste by isolating affected lots instead of discarding entire production volumes. Digital traceability tools such as barcodes, RFID, and sensors enhance transparency and real-time visibility across the supply chain. These systems monitor storage and transport conditions, reduce manual errors, and speed up responses to quality issues. Beyond compliance, digital traceability helps identify loss hotspots and inefficiencies. Raw material usability is evaluated using physical, chemical, and microbiological criteria. Processability and expected yield are key considerations, along with functional performance in specific processing contexts. Economic and environmental valuation further guides decisions on whether materials are accepted, rejected, blended, or redirected to alternative uses.